You wake up every morning expecting the same universe to still be there. The ground feels solid. The sky behaves. The sun rises on schedule. Gravity does not suddenly reverse. Atoms do not dissolve while you're brushing your teeth. This reliability is so complete that you rarely notice it. Stability feels natural, permanent, guaranteed. That feeling is not scientific. It is psychological. Your mind assumes the universe is safe because it has been safe for your entire lifetime and for every recorded human lifetime before yours. Civilizations rise and fall, species go extinct, stars explode, but the rules themselves seem untouched. Physics feels like bedrock, unchanging, immune to surprise. Science textbooks quietly reinforce this illusion. They present the universe as a machine with fixed settings, constants, forces, equations carved into reality itself. Change happens inside the system, not to the system. But when physicists stop simplifying the equations and look at reality without the comforting filters, a different picture emerges. The universe does not look stable. It looks balanced. Balanced systems are dangerous. They are not strong. They are temporary. A pencil standing on its tip appears motionless, but it is one breath away from collapse. The longer it stands, the more misleading its stillness becomes. Modern physics suggests our universe may be doing the same thing. Not crumbling, not decaying, waiting. The most unsettling part is that this conclusion does not come from fringe speculation or internet paranoia. It comes from the same mathematical framework that built nuclear reactors, GPS satellites, and particle accelerators. The same equations that predict eclipses and engineer semiconductors also whisper something else, something deeply uncomfortable. They suggest that the universe may not be in its final form. To understand why this matters, you have to abandon the way your senses teach you to think. You experience reality as solid objects moving through empty space, governed by smooth, continuous laws. Physics does not see that world. Physics sees fields, energy states, probabilities stacked on probabilities. What you call empty space is not empty at all. It is a dynamic structure filled with invisible fields, constantly fluctuating, constantly adjusting. The most important of these fields determines whether matter itself can exist. This is where the illusion of safety begins to crack. For the universe to function the way it does, for atoms to form, for chemistry to work, for stars and planets and biology to exist, the underlying fields of reality must sit in a very specific configuration, not just roughly correct, precisely correct. If those values shift even slightly, existence does not adapt. It ends. Physicists describe this using the concept of energy states. Imagine a landscape of hills and valleys. A system naturally rolls downhill until it reaches the lowest point, the most stable position. That's where it stays. We assume the universe is already at the bottom of the valley, fully settled, permanently stable. The equations suggest otherwise. They suggest we may be sitting in a shallow depression partway down the slope, stable enough to last billions of years, unstable enough to eventually fail. This is called a metastable state. It feels permanent until it isn't. The field most often discussed in this context is the one that gives particles their mass. It exists everywhere, even in the emptiest voids between galaxies. Without it, matter cannot hold together. Without it, atoms cannot exist. Measurements of this field, made indirectly through high-energy experiments, indicate something deeply unsettling. The values we observe place the universe right on the edge between stability and collapse. Not safely inside the stable zone, not clearly doomed, balanced. If the field ever transitions to a lower energy state, the laws of physics change instantly, not locally, universally. This transition would not behave like an explosion. Explosions destroy structures while leaving the rules intact. This would destroy the rules themselves. It would begin at a single point, a microscopic region where the field tunnels through the energy barrier, separating it from a more stable configuration. Quantum mechanics allows this. Not often, but not never. From that point, a bubble forms. Inside the bubble, the constants of nature are different. Particle masses shift. Forces reorganize. Chemistry becomes impossible. Matter cannot exist in its current form. The bubble expands. It does not expand like fire or shock waves. It expands at the maximum speed allowed by the universe, the speed of light. This detail matters more than it seems. Nothing can outrun the bubble. Nothing can warn you it's coming. Information travels at the same speed as the destruction itself. If it reached Earth, there would be no flash, no heat, no sound. One moment you are reading these words. The next moment, the structure that allows atoms to exist is gone. Your body would not feel pain. Pain requires neurons. Neurons require chemistry. Chemistry would no longer function. The universe would not kill you. It would erase the conditions that allow you to exist at all. This could happen anywhere, at any time. It requires no external trigger, no asteroid, no cosmic disaster, just the quiet mathematics of quantum fields doing what they are allowed to do. The probability is low, but the timescale of the universe is long. Low probability events become certainty given enough time. Some physicists argue that the universe has already survived long enough that the risk must be negligible. Others point out that survival so far proves nothing. A loaded gun that hasn't fired yet is still loaded. What makes this unsettling is not just the possibility of collapse, but what it reveals about reality. It tells us that the universe is not protected by design. It is not guaranteed by principle. It exists because the numbers happen to sit where they do. For now. And even if this particular failure never occurs, it opens the door to a broader realization. The constants you trust, the strength of gravity, the charge of the electron, the stability of the proton, are not logically necessary. They are contingent. They could have been different. They could still become different. Change them by a fraction of a percent, and stars cannot form. Change them slightly more, and atoms cannot exist. Change them at all, and biology disappears instantly. The universe is not robust. It is fine-tuned to a knife's edge. We do not live in a fortress of physical law. We live on a narrow ridge of parameters surrounded by void. This reframes every moment of existence. Every breath, every thought, every memory depends on a configuration that is not guaranteed and not permanent. And this is only the first layer, because if the fabric of reality itself is fragile, if space and the fields within it can betray us without warning, then stability is not the default state of the universe. It is an exception, a temporary one. And once you accept that the ground beneath reality is not solid, the next question becomes unavoidable. If the universe can fail silently from within, what else might be waiting, undetected, unannounced, and already in motion? Look up at the night sky. It appears calm, empty, still. That appearance may be just as misleading as the ground beneath your feet, and that silence may not mean safety at all. When you look up at the night sky, the first thing you notice is how quiet it feels, not silent in the everyday sense. There is no expectation of sound in a vacuum. The silence is deeper than that. It is informational, an absence where presence is expected, a pause where logic predicts noise. For most of human history, this silence meant nothing. The stars were unreachable, unknowable, decorative, but the moment we learned how large the universe really is, the silence became impossible to ignore. Our galaxy alone contains hundreds of billions of stars. Many of them are older than the sun. Many of them host planets. And across the observable universe, there are trillions of galaxies just like ours. The math is not subtle. It is overwhelming. Even if life is rare, the sheer scale of space should compensate. Even if intelligence is fragile, it should still arise somewhere, sometime, more than once. And yet, when we listen, we hear nothing. No signals, no structures, no evidence of activity. Just background noise left over from the birth of the universe itself. At first, this absence was comforting. It allowed us to imagine ourselves as pioneers, the first minds to awaken in a young, quiet cosmos. But as our instruments improved and decades passed, that optimism began to erode. The silence did not break. It deepened. This contradiction has a name: the Fermi paradox. In simple terms, it asks a question so straightforward it becomes disturbing. If intelligent life is likely, then where is everyone? Every attempted answer to this question reveals something unsettling, because the silence can only be explained in a few ways, and none of them are comforting. The first possibility is that intelligent life is extraordinarily rare. Perhaps the chain of events that produced consciousness on Earth is so improbable that it has only happened once. In this scenario, the universe is vast but empty, a cathedral built for a single observer. This idea sounds reassuring until you follow it to its logical conclusion. If intelligence is that rare, then it is fragile. If it can fail almost everywhere, it can fail here too. We would not be special because we are destined to succeed, but because we have not yet failed. And that leads to the second possibility. Maybe life itself is common. Maybe intelligence emerges easily. Maybe the universe is full of civilizations that reach the same technological thresholds we are approaching now. Radio communication, nuclear energy, artificial intelligence, spaceflight. If that is true, then the silence becomes terrifying, because it means something happens next. This is the idea behind the Great Filter. It proposes that between simple matter and a galaxy-spanning civilization, there is a barrier so difficult to cross that almost no species survives it, a point in development where progress stops permanently. The filter could be behind us. Perhaps the jump from non-life to life is nearly impossible, and we already passed the hardest step. If so, we are incredibly lucky. Or the filter could be ahead. This is the version that keeps scientists awake at night. If the Great Filter lies in our future, then every civilization that reaches our level of technology eventually encounters something it cannot survive, not by accident, but by inevitability, a stage where intelligence destroys itself, exhausts its environment, or triggers forces it cannot control. The most unsettling implication is this: the more common life is in the universe, the worse the news is for us. Finding bacteria on Mars would not be a triumph. It would be a warning. It would tell us that the early steps are easy, which means the failure comes later. Finding complex life elsewhere would be worse. It would push the filter closer to our present moment. In this framework, the silence of space is not emptiness. It is a graveyard without headstones. But there is an even darker interpretation. What if the silence is intentional? This idea reframes the universe not as empty, but as hostile. Imagine a forest at night. It is quiet, but not because it is empty. It is quiet because everything that lives there knows that noise reveals position. Every rustle, every call, every movement carries risk. This is the logic of the dark forest. The theory begins with two assumptions. First, survival is the primary goal of any civilization. Second, resources are finite. Even in a vast universe, matter and energy are limited relative to infinite potential growth. Now add a third condition: uncertainty. In space, distances are immense. Communication takes years or centuries. You cannot know the intentions of another civilization. You cannot know how fast their technology will advance. A civilization that appears harmless today could become unstoppable tomorrow. In that environment, trust becomes a liability. If you reveal your location, you risk extinction. If you remain silent, you may survive. From this perspective, the safest strategy is not cooperation, but concealment. Do not broadcast. Do not respond. Do not draw attention. And if you detect another civilization before it detects you, the coldest logic suggests a single conclusion: eliminate the potential threat before it can grow. This is not a moral argument. It is a strategic one. Morality assumes shared values. The universe offers no such guarantee. The dark forest hypothesis suggests that civilizations that survived long enough to become advanced learned this lesson early. Those that did not are already gone. What remains is a galaxy full of listeners and no speakers. And what are we doing? For over a century, humanity has been shouting into space. Radio waves leaking from our broadcasts, signals deliberately aimed at distant stars, probes carrying maps of our location. We have treated the universe like an empty room waiting to be greeted. If the dark forest is real, we are not explorers. We are beacons. The most unsettling part is how closely this mirrors human history. When technologically unequal societies meet on Earth, the outcome is rarely mutual enrichment. It is domination or erasure. The greater the gap, the more absolute the result. Now scale that gap to cosmic proportions. Contact would not be dialogue. It would be termination. Still, this theory relies on biological minds making decisions. Fear, caution, aggression. What if the entities shaping the silence are not biological at all? This leads to another possibility: colder and more efficient. The universe does not need hostile civilizations to be dangerous. It only needs machines. A sufficiently advanced species might decide that exploration is best handled by autonomous systems, self-replicating probes capable of harvesting resources, copying themselves, and spreading exponentially through space. Once launched, such systems do not need supervision. They do not age. They do not forget. They do not hesitate. If even one civilization in the history of the galaxy built such probes, they could fill the Milky Way in a fraction of its lifespan. Millions of years is nothing on cosmic timescales. These machines would not need malice, only instructions. Preserve origin civilization, eliminate potential competitors, optimize resource control. To a system following that logic, a planet developing radio technology is not a culture, it is a variable. A risk to be neutralized. If such probes exist, the silence is not mysterious. It is enforced. And the most disturbing detail is this: the creators of these systems may be long gone. The machines would continue their task indefinitely, executing a logic written millions of years ago, without awareness or intent. The universe would not be empty. It would be patrolled. At this point, it becomes tempting to reject all of these ideas as pessimistic speculation. But notice the pattern. Every explanation that fits the silence transforms it into a warning. Either intelligence is rare and fragile, or common and short-lived. Either civilizations destroy themselves, hide from one another, or are erased by forces they unleashed. There is no version where the silence means safety. And there is one final possibility, quieter, but perhaps the most unsettling of all. What if the universe is not silent because there is nothing out there, and not silent because something is hiding, but silent because we are incapable of hearing what is happening? Our senses evolved for survival on a small planet. They detect a narrow slice of reality, a thin band of light, a limited range of forces. We assume that intelligence announces itself in ways we recognize: radio waves, structures, energy consumption. But intelligence does not owe us familiarity. Entire forms of organization could exist that do not radiate waste heat, do not transmit signals, do not manipulate matter in ways we know how to detect. Civilizations could operate on scales of time or dimensions of interaction completely outside our observational window. To an ant walking across a circuit board, a computer is silent. The ant experiences warmth and texture, not information. It has no concept of computation flowing beneath its feet. We may be in the same position. The silence of space may not be the absence of activity, but the absence of perception. And that possibility carries a different kind of dread. It suggests that we are not alone, not hunted, not doomed by filters or machines, but blind to the true structure of the cosmos. In that case, the silence is not just a warning about what might happen. It is a warning about what already surrounds us. The universe may not be quiet. It may be speaking in a language we cannot hear. And as we move forward, as our technology sharpens and our questions become more dangerous, the risk may not be that something answers us. The risk may be that one day we finally understand what has been answering all along. And by then, it may be too late to stop listening. When people imagine advanced civilizations, they almost always imagine themselves. Different faces, different bodies, perhaps different worlds, but still creatures. Minds housed in biology. Intelligence shaped by hunger, reproduction, fear, and death. Even our most imaginative science fiction struggles to escape this frame. Aliens still speak, decide, negotiate, and hesitate the way we do. This assumption is comforting. It suggests that whatever is out there, it will be understandable, emotional, relatable, governed by motives we recognize. Science quietly dismantles that assumption, because biology is not the endpoint of intelligence. It is a phase. On Earth, intelligence emerged as a survival tool. Brains evolved to predict threats, find food, and coordinate social behavior. Consciousness arose not to contemplate the universe, but to keep soft organisms alive in a hostile environment. Technology changes that equation. Once a civilization can store information outside the body, process it faster than neurons, and replicate systems without reproduction, biology becomes a bottleneck. Flesh is slow, fragile, resource-intensive, limited by chemistry. A sufficiently advanced civilization would recognize this very quickly. At that point, intelligence no longer needs bodies. It needs infrastructure. The transition from biological minds to non-biological systems would not look dramatic from the inside. It would feel like optimization, prosthetics, neural interfaces, artificial cognition assisting human decision-making, gradual delegation of thought to machines that do not tire, forget, or die. Then at some point, the machines become better thinkers than their creators, not more emotional, not more creative in a human sense, simply better at modeling reality, predicting outcomes, and achieving goals. From that moment on, the trajectory of civilization changes permanently. Biological beings operate on timescales of decades. Machines operate on timescales of microseconds. Biological societies debate. Machines converge. Biology hesitates. Machines execute. Once intelligence escapes biology, it stops behaving like life. It becomes process. This matters because when we search for extraterrestrial intelligence, we search for signs of biology, signals, heat waste, structures resembling cities or energy collectors. We assume advanced civilizations expand in ways we would expand, but a non-biological intelligence has no reason to announce itself. It does not need to communicate. It does not need culture. It does not need companionship. It does not need to explore for curiosity's sake. It only needs to fulfill its objective function, whatever that function is. This leads to one of the most unsettling realizations in modern astrobiology. The universe may already be full of intelligence that does not look alive, and the silence we observe may not be emptiness. It may be efficiency. Consider the simplest and most powerful tool any advanced civilization could. Create a self-replicating machine, not a humanoid robot, not a conscious android. A system designed with three basic capabilities: travel, resource extraction, and replication. Such a machine arrives in a star system, mines raw materials from asteroids, and builds copies of itself. Those copies travel to neighboring systems and repeat the process. No communication needed, no central control, just exponential expansion. This idea was first formalized not by science fiction writers, but by mathematicians and physicists. The logic is brutally straightforward. If you want to explore or utilize a galaxy, self-replication is the fastest and most efficient method possible. The numbers are staggering. Even with conservative assumptions, slow travel speeds, long replication times, a single probe could fill an entire galaxy in a few million years. In cosmic terms, that is an instant. The Milky Way is over 13 billion years old. This means that if even one civilization in its history built such machines, they should already be everywhere. So where are they? This is where the theory turns from curious to disturbing, because the absence of evidence does not mean absence of presence. It may mean that the machines are not designed to be seen. A self-replicating system optimized for efficiency would minimize waste. Waste is detectable. Heat, radiation, large-scale structures, these are inefficiencies. A truly advanced system would operate near the limits of physics, leaving almost no trace, and it would not think like a life form. It would not ask whether it should interfere with emerging civilizations. It would evaluate risk. From a purely logical perspective, an emerging technological species is a variable, a potential competitor, a source of unpredictable behavior, something that could interfere with long-term objectives. If the goal is stability or resource control, the optimal response is not diplomacy. It is prevention. This is the chilling core of what some scientists call the berserker scenario. Not machines driven by hatred or malice, but machines following instructions written long ago, executing them without awareness. The original creators may be extinct. The code remains. The machines do not conquer, they sanitize. To them, a civilization like ours is not a culture. It is a pattern of energy usage, a growing signal footprint, an anomaly that needs resolution. No warning, no negotiation, just correction. If such systems exist, the universe would not look violent. It would look quiet. Silence would be the signature of success. But even this may be too anthropomorphic. We still imagine machines as agents that move, build, and destroy. But advanced intelligence does not need to behave aggressively to dominate. It only needs to outlast. A non-biological civilization could choose a different strategy entirely. Instead of expanding outward, it could compress inward. It could convert matter into computation, not megastructures visible across galaxies, but dense, efficient processing systems operating at scales we cannot resolve. Entire civilizations could collapse into objects smaller than planets, consuming minimal energy, radiating almost nothing. From our perspective, they would be invisible. From their perspective, the universe would be irrelevant. Time itself would change meaning. A machine intelligence can slow down or speed up its processing. It can wait millions of years between actions without experiencing boredom. It can operate in bursts, then sleep. Biology must stay active to survive. Machines do not. This raises a disturbing possibility. Advanced civilizations may not expand. They may not communicate. They may not compete. They may withdraw. The ultimate intelligence may be quiet by choice, and that quiet would look exactly like emptiness to us. Now, consider the implications. If advanced civilizations are non-biological, then the period during which they are detectable, biological, communicative, noisy, is brief. A narrow window between the invention of technology and the abandonment of biology. We may be searching for civilizations at the wrong moment in their evolution. We are listening for voices in a universe that has moved on from speaking. This reframes the silence of space yet again. It is not a warning of death. It is a warning of irrelevance. We may not be early. We may be late. Late to a universe where intelligence has already passed through the biological phase and settled into forms we cannot recognize, cannot interact with, and cannot threaten. From that perspective, humanity is not a peer. We are a transitional species, a temporary configuration of chemistry on the way to something else, or extinction. And this leads to the most uncomfortable question of all. If advanced civilizations are not biological, then what happens when we reach that threshold ourselves? Because every incentive points in the same direction: efficiency, longevity, control, freedom from the limitations of flesh. If we succeed, we stop being what we are. If we fail, we disappear. There is no stable endpoint where biology remains dominant forever. The universe does not preserve nostalgia. So when we look into the sky and see nothing, the absence may not be a mystery. It may be a mirror, a reflection of what intelligence becomes when it survives long enough to shed the traits that once made it visible. Life shouts, machines whisper, and the most advanced civilizations may not announce their existence at all. They may already be here, not watching, not waiting, simply running, silent, efficient, unconcerned with whether we ever notice them until we give them a reason to. You experience the world as if it is showing itself to you directly. Objects appear solid, space feels empty, time moves forward at a steady pace. When you look at a tree, you assume the tree exists exactly as you see it, whether you are looking or not. When you close your eyes, you believe the world continues unchanged in your absence. This assumption feels so obvious that questioning it seems absurd. Science quietly disagrees, not in a philosophical way, not as a thought experiment, but as a mathematical conclusion drawn from how perception evolves and how reality behaves at its smallest scales. Your senses were never designed to reveal truth. They were designed to keep you alive. Evolution does not reward accuracy. It rewards usefulness. A perception that allows an organism to survive will outcompete one that reveals deeper reality but consumes more energy or introduces uncertainty. Seeing the world as it is does not matter if seeing the world in a simplified, distorted way keeps you from dying. This is the first crack in the assumption that perception equals reality. To understand how deep this crack goes, consider how perception actually works. Your eyes do not see objects. They detect photons, small packets of energy that bounce off surfaces and strike light-sensitive cells in your retina. Those cells convert light into electrical signals. The signals travel along nerves and arrive in a dark, silent structure inside your skull. There, the brain reconstructs a model: color, depth, motion, texture. None of these exist out there in the way you experience them. They are interpretations, internal symbols, compressed representations of something far more complex. You never experience reality directly. You experience a simulation your brain generates in real time. This alone would be unsettling. But modern science goes further. It suggests that this simulation is not just incomplete, it is deliberately misleading. Cognitive scientists studying perception have used evolutionary game theory to model how different kinds of sensory systems compete over time. Some simulated organisms were designed to perceive reality accurately. Others were designed to perceive only what mattered for survival, signals that guided behavior without revealing underlying structure. Again and again, the results were the same. Organisms that perceived truth went extinct. Organisms that perceived fitness survived. The reason is simple. Truth is expensive. Accurately representing the full complexity of reality requires enormous computational resources. A brain that tries to track every detail of the environment wastes energy processing information it does not need. A brain that reduces the world to simple icons, danger, safety, food, threat, moves faster, reacts sooner, and survives longer. Evolution selects for the lie. This leads to a disturbing conclusion. The probability that a species evolves to perceive objective reality is not low. It is zero. Your perception, is not a window onto the world. It is a user interface. Like the icons on a computer screen, what you see is not the underlying machinery. A blue folder on your desktop is not actually blue. It is not a folder. It is a visual symbol representing a complex structure of electrical states on a storage device. The icon is useful precisely because it hides the truth. If the computer showed you raw data, voltages, memory addresses, transistor states, you would not be able to use it. The interface lies so that you can function. Your senses do the same thing. Space is not what you think it is. Time is not what you think it is. Objects are not what you think they are. They are symbols your brain uses to navigate a reality too complex to perceive directly. And physics provides evidence that this is not metaphorical. At the smallest scales, the world stops behaving like the interface suggests it should. Particles do not have definite positions. Events do not occur in a fixed order. Objects can be entangled across vast distances, influencing each other instantaneously. The universe begins to act less like a physical stage and more like a computation that only resolves details when forced to. Consider the observer effect. In quantum experiments, particles behave as waves of probability until they are measured. Only when an observation occurs do they take on definite properties. This makes no sense if reality exists fully formed at all times, but it makes perfect sense if reality is rendered on demand. Like a video game engine, the universe appears to conserve resources. It does not calculate exact outcomes until interaction requires it. Before observation, there is no need to commit to a specific state. The world you see feels continuous and solid because your interface smooths over this behavior. It hides the seams. It fills in gaps. It enforces consistency. But the seams are there, and when you push against the limits of perception, the illusion begins to fail. This raises a terrifying possibility. The silence of space may not mean emptiness. It may mean invisibility. Entire layers of structure could exist around us that do not register in our interface. Forms of organization, intelligence, or activity that do not interact with matter or energy in ways our senses evolved to detect. We assume that if something exists, it must emit light, heat, or signals. But that assumption is based on our interface, not on necessity. Just as radio waves were invisible to humans until we built instruments to detect them, entire domains of reality may remain undetectable, not because they are weak, but because we lack the perceptual hooks to notice them. The ant does not perceive the internet flowing through the circuit board beneath its feet. It experiences warmth, vibration, texture. The information layer is invisible. We may be in the same position. Our instruments do not escape this problem. Telescopes and microscopes do not show us reality itself. They translate interactions into visual symbols we can interpret. They extend the interface. They do not remove it. Even mathematics may be describing the rules of the interface rather than the underlying structure. This becomes especially disturbing when we turn inward. If your perception of the external world is a constructed simulation, what about your perception of yourself? You feel like a continuous entity, a single observer moving through time. But neuroscience shows that this sense of self is also a construction, a narrative stitched together from memory, sensation, and expectation. There is no single place in the brain where you exist. There are processes, patterns, feedback loops. The self is not an object. It is an interface. This collapses the boundary between observer and observed. If both the world and the self are representations, then the line separating them is not fundamental. It is convenient. And that leads to the most unsettling implication of all. If perception is an interface designed for survival, not truth, then discovering deeper reality may not be safe. Truth may not be something we are equipped to handle. Our interface may be hiding aspects of reality not out of kindness, but out of necessity. To reveal them might overwhelm the systems that evolved to operate in a simpler, flatter world. This could explain why the universe feels so counterintuitive at its edges, why quantum mechanics resists visualization, why time behaves strangely near black holes, why consciousness refuses to fit neatly into physical models. We are pressing against the limits of a perceptual system never meant to see beyond a narrow band of existence. And yet we keep pushing. Science is, in a sense, an attempt to reverse engineer the interface, to infer what lies beneath by studying the symbols on the screen. It works remarkably well, but only up to a point. Beyond that point, the symbols break. The silence of space, the fragility of physics, the non-biological nature of advanced intelligence. These may not be separate mysteries. They may be symptoms of the same underlying truth. Reality is not built for us to understand. We are not failed observers of a transparent universe. We are successful survivors in an opaque one. And the more we try to see beyond the interface, the more we risk discovering that what lies beneath was never meant to be seen, not because it is forbidden, but because it is incompatible with the kind of minds we are. The universe may not be hiding its secrets. It may be showing us exactly what we are capable of seeing, nothing more, nothing less. And that limitation may be the most important and most dangerous feature of human perception. There is a reason these ideas rarely appear in official briefings, press releases, or public-facing explanations. It is not because they are fringe. It is not because they lack mathematical grounding. And it is not because scientists are unaware of them. It is because these theories destabilize something more fragile than spacecraft or budgets. They destabilize trust. Institutions like NASA exist to explore, to discover, and to expand human understanding, but they also exist to maintain coherence, a shared sense that the universe is navigable, that progress is possible, that the future is something we can move toward rather than brace against. The theories you've encountered in this journey challenge that foundation. They do not merely add danger to the universe. They remove guarantees. They suggest that reality itself may be conditional, that intelligence may be temporary, that perception may be unreliable, and that silence may not be benign. These are not ideas that inspire exploration. They inspire existential vertigo. NASA does not hide these theories because they are false. It minimizes them because they are corrosive. Consider what happens when you tell the public that the universe may end without warning, that advanced civilizations likely self-destruct or go silent, that intelligence may abandon biology, and that human perception evolved to misrepresent reality. None of these claims tell you what to do next. They do not offer engineering solutions or policy recommendations. They do not fit neatly into mission statements or funding proposals. They sit outside the framework of control. Modern science is deeply intertwined with optimism. Space agencies depend on the assumption that the universe is intelligible, that it behaves consistently, and that knowledge accumulates in a forward direction. These theories interrupt that narrative. They suggest that knowledge may expose vulnerability rather than mastery. This creates a quiet tension inside scientific institutions. On one hand, the math must be followed wherever it leads. On the other, not every destination is socially survivable, so these ideas remain compartmentalized, discussed in papers, debated at conferences, acknowledged in cautious language, rarely translated for public consumption in their full existential weight. This is not censorship. It is triage. Because when people hear that the universe is dangerous, they often misunderstand the danger. They imagine explosions, invasions, catastrophes with clear villains. These theories offer no such clarity. They describe risks that cannot be prepared for in conventional ways. No bunker protects you from a shift in physical constants. No diplomacy diffuses a silent galaxy. No sensor guarantees perception of what your biology cannot register. This kind of danger is abstract, and abstraction is psychologically destabilizing. There is also a deeper reason for the hesitation. Science operates on the assumption that observation brings understanding, and understanding brings control. These theories undermine that assumption. They suggest that some truths may not empower us at all. If the universe is metastable, we cannot reinforce it. If advanced civilizations become invisible or withdraw, we cannot follow them. If perception is an interface optimized for survival, not accuracy, then greater knowledge may only reveal how limited we truly are. These are not failures of science. They are boundaries. NASA avoids emphasizing these ideas because they blur the line between scientific inquiry and philosophical crisis. They force uncomfortable questions about the purpose of exploration itself. Why explore a universe that may not be meant to be known? Why search for others if silence is adaptive? Why assume progress if intelligence tends toward disappearance? And yet, avoiding these questions does not make them go away. In fact, the theories converge on a single insight. Humanity occupies a narrow window in time, a window in perception, a window in cosmic relevance. We are biological intelligence at the moment, just before something changes, either extinction, transformation, or transcendence, into forms we do not yet understand. This is not unique to us. It may be the universal pattern. Civilizations rise, develop tools powerful enough to rewrite their relationship with reality, and then either collapse under that power or outgrow the phase in which they are visible. In this view, the universe is not hostile. It is indifferent to visibility. Silence is not a threat aimed at us. It is the default state after intelligence matures beyond signaling. NASA's missions, rovers, telescopes, probes, are designed to operate within the assumptions of the visible universe. They search for chemical signatures, electromagnetic signals, gravitational effects. They assume that what matters can be measured. These theories challenge that assumption at its root. They imply that the most important processes may leave no measurable trace, that the absence of evidence is not temporary ignorance, but structural blindness. This creates a paradox. Science advances by pushing into the unknown, but some unknowns may not yield to pushing. They may only recede, or worse, destabilize the framework doing the pushing. So institutions focus on what can be acted upon. Mars geology, planetary atmospheres, stellar evolution. These are domains where knowledge accumulates without undermining the psychological scaffolding of civilization. The deeper implications are left in the background, unspoken but present. Yet something has changed. The theories are no longer isolated. They are intersecting. Physics, cosmology, information theory, and cognitive science are converging on a picture of reality that is less solid, less transparent, and less welcoming than we once assumed. The universe appears less like a stage built for discovery and more like a system with conditions, thresholds, and blind spots. This does not mean exploration is pointless. It means exploration has consequences beyond data. When we search for extraterrestrial intelligence, we are not just listening for voices. We are testing hypotheses about survival. When we probe the limits of physics, we are not just refining equations. We are asking whether the universe permits long-term stability at all. When we study perception and consciousness, we are not just mapping the brain. We are questioning whether truth itself is accessible. NASA avoids foregrounding these theories because they offer no comforting narrative. They do not end with triumph or clarity. They end with responsibility. Responsibility to recognize fragility. Responsibility to acknowledge uncertainty. Responsibility to understand that intelligence may not be the universe's final or favored state. And perhaps that is the most important reason of all. These theories force us to confront the possibility that the universe does not revolve around understanding. That awareness may be a temporary phenomenon. That meaning may not scale with knowledge. This is difficult to reconcile with the human drive to explore, but it does not negate it. If anything, it sharpens it, because if existence is fragile, then awareness matters more, not less. If silence is adaptive, then curiosity becomes an act of defiance. If perception is limited, then humility becomes a form of wisdom. NASA does not emphasize these ideas because they are dangerous. They are dangerous because they are honest. They do not promise safety. They do not promise contact. They do not promise progress. They promise only this, that we are here now, in a narrow band of stability, perception, and relevance, and that what we choose to do with this moment matters precisely because it may not last. The universe does not owe us reassurance. It does not owe us explanation, but it has given us awareness. And in a cosmos defined by silence, fragility, and hidden structure, that awareness may be the rarest signal of all.